So up on the board right now, I have y equals 3 minus x. Y equals 3 minus x. If I asked you to graph it, so for instance, I go to my graphing calculator, I type in 3x minus 6. When I hit that graph button, what's it going to show me? A line. That's all I need. That's all I need from you. I don't need any more details. Does everyone agree? When I hit the graph button, I see a line. Anything in the form of y equals mx plus b will be a line. You like that, by the way? Anybody like that magic right there? I know that was pretty good. All right. Well, it's going to be a line. All right. Now let me go on. Now this is where it just became total chaos. X squared minus 2x minus 24. I go back to my calculator. Clear that out. X squared minus 2x. I'm actually going to, I'll do minus 24. Anybody remember what you call that when I hit the graph button here? Ooh. This is where people are like, I start to get nervous and I sweat. You got it, Radhika?
Would it be a palabra?
What was that?
Oh, wait.
What was that? Was that German?
Palabra? I don't know.
A palabra. That's a new term I've heard. You're close. I'm joking. You're close. Parabola. Yes. You guys exposed to that in Algebra 1, I hope? A parabola? Okay. Yes. Anything with x squared is going to be a parabola. Correct. All right. So anything with x squared will be a parabola. And my last one that you should have been exposed to last year, 2 to the x. Y equals 2 to the x. What type of graph that'll be? Anybody remember what it looks like? No? What's up? What do you got, Will?
It's like an exponential graph.
It's called exponential, yes. You remember what it looked like?
Kind of, yeah.
Right? Going uphill or downhill pretty darn quickly. All right. So those are the types of graphs I think you have seen in your math career, most likely last year in Algebra 1. Now, why am I showing you these? Because today, in the unit we're in, circles, they also have an equation. Circles, you can graph circles, and that's what we're going to do today. Here is the equation of a circle. It's pretty beefy. It is pretty beefy. X minus h all squared plus y minus k all squared equals r squared. Wow, that's a lot to it. So let me take my time right now and tell you what each piece is about. All right, you're going to have a number plugged in for h and for k. And for h and k. You're seeing numbers there. Just like, hey, don't you always see numbers plugged in for m and b? Right? Yeah, you do. That's the slope and the y-intercept. Well, h and k are the center of the circle. Those numbers you see plugged in for h and k represent the center of the circle. The h is the x-coordinate of the center. K is the y-coordinate of the center. And then on the other side of the equal sign, you're going to see a number plugged in as well. That number is not the radius length. It's whatever the radius length is squared. Okay? So whatever number I see here, I got to be disciplined today and say, that's not the radius length. That's whatever the radius length is squared. So let me show you an example of a circle equation with numbers plugged in. And we can talk about it. So right underneath, here's an example. I'm going to plug actual numbers in right now. Ready? X minus 2 all squared plus y plus 5 all squared equals 100. That is an example of an equation of a circle. Now let's talk. What do I know about the circle now, given that equation? Well, right here are your h and your k values. So you should be able to tell me what the center of this circle is. Where is the center of this circle located on the graph? What number is in for h? Well, remember the equation is x minus h. I have x minus what? What's in place of h? 2. So there's your x coordinate of the center. Here's where you got to be careful. It's y minus k. So what number must I have plugged in for k for this to turn into a positive 5? Negative 5. So the center of this circle is positive 2, negative 5. That's where the center lies. The other thing you can peel off from this equation, how long the radius is. The radius length. The radius length is not 100. The 100 represents whatever the radius length is squared. So if I see 100 there, what's the radius length? 10. Sophia, go ahead, ask your question.
So what are x and y? Just a part of the circle?
Now let me talk about that. That is correct. X and Y represent a point on the circle. It's very, very similar to, let me go back to y equals mx plus b. When you write the equation of a line, you guys never plug in for y or x, unless you need to. Y and x are always points on the line. Same thing here. Y and x represent points on the circle. All right, so does everyone see the equation of the circle? I can get the center from it, and I can get the radius length from it. Okay, those are the two things I can get. Anything you want to ask before we go into actual questions here? All right, next. Now I want you guys to write the equation. I'll give you the information you need. You give me the equation back. So 1a, I got a center at 3, negative 3, and a radius of 6. Write the equation now. Write the equation. Remember, the only things you guys should be plugging in for, h and k, which is the center, and the radius length. Those are the only two things I got to plug in for. All right, here we go. Someone's up. First person of the day here, helping me out. Let's go 8. Ryan, going home. Ryan, ready to go here. So I'm going to start this off with x. What's your h value, Ryan?
Is it 2?
No. What's the center of the circle here? I'm on 1a. 1a.
1, 3?
No. You're looking at part B. I'm looking at part A. You see part A?
Yeah.
Okay, so you see the center. What's the x coordinate of the center?
Oh, okay. 3.
3, so it's going to be x minus 3 all squared. What's the y coordinate of the center, Ryan?
Negative 3.
Okay, so now, everyone, it becomes what? Not y minus 3, but y plus 3. Everyone see it? Because it's y minus a negative 3. And then finally, Ryan, what's your radius length?
6.
But I don't put a 6 there. I put whatever the radius is squared. So what number do you want me to put there, Ryan?
36.
There you go. So there is the equation of this circle with those details. And that's it. I leave it alone. Leave it alone. Hey, don't pull this on me. Oh, he did this last week. I'm going to go x minus 3, x minus... No. I don't need that. There's your equation of the circle right there. We're done. Leave it. We're done. All right, so part A, I gave you everything you needed. Now can you do it from a graph? Can you pull the center and the radius length off of this graph and write the equation?
You're given a point of a circle here, but would you plug that into the equation?
You won't need to, because you should, from this graph I am giving you in part B, you should be able to identify what the center and the radius is already. So I don't need to plug it back in. Those are the two things you need to write the equation of a circle. What's the center? What's the radius? All right, let's do this. Let's go 2-4. Emily, good morning, Emily. Emily, what's the center of this circle first?
1, 3.
Okay, thank you. 1, 3. All right, go ahead. Can you start with the equation for me? X.
Minus 1.
Yep. All squared plus y.
Minus 3.
Minus 3. How long's the radius, Emily?
2.
2. So what do I want to plug into the right side of my equation?
4.
4. There you go. The radius squared has to go there. Questions, kids? All right, not too bad. And then part C, yes, I do give you the center and radius, but I'm kind of interested what you're going to do with the square root of 26. Kind of interested there what you're going to do. All right, here we go. Help me out with this equation. I'll help you out if you need it. I don't have one anymore. I do have one of those. Ryan, on fire today. Let's go, big dog. What do you got in that first set of parentheses?
I got x minus 0 squared
Got it. Second set.
plus y plus 2 squared.
Good. -2 becomes +2. Now, Ryan, if the radius length is 26 and I got to put in the radius length squared, what number do you think I'm going to put there?
26.
There you go. Good. If somebody's wondering why I'm putting 26 there, take a look. This number is always the radius, radical 26, squared. And I think we've talked a lot this year. Anytime you square a radical, you get the number underneath. Even if you're unsure, your calculator will do it. But before I go to the next problem, hold on. This is a good answer Ryan gave me. Good answer. Might not be a multiple choice answer on a quiz, though. Here's why. You can keep simplifying. X minus 0 is just x, so you may see this instead. X squared. If you see that, hey, that must mean the x coordinate is 0. If you see y squared all by itself, that must have meant the y coordinate was 0. So just a heads up there. All right. Anything else before we go to a little bit more, a little different one? All right, now I'm on a graph now. Write the equation of this circle. Let's see. The center is at -3, 1, 2, 3, 2. And the circle goes through 1, -2. I got to change this next year. It's too easy. I don't know why we didn't change it this year. All right, so center, that's done, right? The center's done. Guys, if this is the center, my red dot, and the green dot is a point on the circle, if I connect those two, can you guys give me another name for that segment I just made? That's the radius. Everyone at home, that's the radius. It's way too easy. I got a challenge question at the end here for you, though, because you're not going to see that tonight. All right, help me out. What should go in my equation now? You already know the center. It's just a matter of how long is the radius. Ooh, everyone at home today. Ellie, good morning. Here you go. Well, you want to start this equation off for me, Ellie?
So first you would have x plus 3 squared.
Good start. Yep.
And then y plus 2.
Good job.
squared,
All squared. And then what should go on the right side now?
16.
Good job. Radius length is 4 because Ellie can count. All right, radius length is 4 because you can count. And then she squares it, gets 16. Challenge question, though. Hey, kids, watch what I'm about to do. That was too easy for you. Let's say it goes through 2, 3. 2, 1, 2. Let's say it goes through that point now. All right. I'm not going to do this with you, but I think it comes up on homework tonight. Now, that's the radius right here. You can't count it. What are you guys going to do to find the length of it then? You could use distance formula. Yep. Mm-hmm. You guys remember the distance formula? There you go. Hey, quick question here, and I'm only doing this because you're honors. If I asked you to solve for r, what would you have to do to r to get r squared by, or r? What would you have to do to r squared to get r by itself?
Take the square root.
Where do you think the circle formula comes from? Distance formula. It's the same thing.
Okay, so, it's not really important, but if
No.
you have the radical and you have the center and the square, can't you go, let's say the radical is more like the question, you could go for it from the center in all four directions, and you have the circle.
That's what we're about to, what do you mean, actually graphing it?
Yeah.
Yes. Up, down, left, right. That's what we're about to do. Yep. It's important. We're about to do it. Okay, so again, if you can't count the radius tonight, you're going to have to use distance formula. All right, speaking of graphing a circle, let's do it. And please disregard the directions. You will need a compass where, once the Regents was put to bed, there's no, let me back up. Forget about the Regents. How about that? We're not all in class at the same time. Some of us are home all the time. So using a compass is kind of out of the question this year, unfortunately. I tried it, but too many people use their Chromebooks, and that's kind of hard to do with the compass. So freehand it. Okay, you can freehand it. I'm fine with that. As much as that pains me to say and to look at, you can freehand it. All right, graph the circle. Well, if you're going to graph it, you're going to need two things. Where do I start? The center, and then how long is the radius? So this is kind of doing the opposite of what we've been doing all day in class. I've given you both, and you wrote the equation. Now I'll give you the equation, and you pull them out. All right, let's do it. What's the center and the radius here? Here we go. Sabrina, good morning. You got the center for me, Sabrina? If I have a -2 and a +1 in there?
2, -1.
Good job. Yep, 2, -1. And if anybody's picking this up, yes, you just do the opposite of what's there. Yes. And Sabrina, how about the radius length if I have a 36 there? 6. Yep, I just do the square root of 36, and that's 6. All right, graphing it now. I don't know if anybody at home heard the conversation Hannah and I just had. How do I graph a circle? Graph the center first. 2, -1. And then from there, you should be able to graph 4 more points that are actually on the circle using the radius of 6.
Just 6 out in every direction.
Up, down, left, and right, 6 units. So from the center, up 6, right 6, down 6, left 6.
Say the form.
I don't even want to know what some of yours look like right now if I ask you to freehand it.
Deform the diamond.
All right. So find the center, up, down, left, and right, the radius length, and you got your circle. Questions? Because now I'm actually going to give you about a 30-second break right now because we're in for it for these last 2. All right, we're in for it. If you have a compass and want to use it, I'm not going to tell you not to. Okay, I just don't want to force, especially if you're taking notes on the Chromebook, I don't expect you to use a compass.
The Chromebook is a circle tool, though.
Use the circle shape.
Yeah.
Oh boy. All right, you ready, kids? You ready? In class, at home, hope you're ready now. I'm asking you to graph that, and some of you are going to say, I don't like that. That's not in the form we've been using all today, and you're correct. That's still a circle, though. That is still the equation of a circle. That's what's called standard form of a circle. When x's and y's all on the same side, this is called the standard form of a circle. What have we been working with today? A different form. X minus h all squared plus y minus k all squared equals r squared. This is referred to as circle radius form. Center radius form. This is called center radius form. Pretty clever, huh? I'm getting rattled. It's kind of like, remember graphing a line, you had slope intercept, point slope, standard form, same thing with the circle, there's different versions. All right, you ready? I need your help going from standard form, because I don't know what the center and radius is in standard form. I don't know how to do that, but I know how to graph if it's in center radius form. So now we need to convert standard to center radius. How are we going to do that? Using, I hope, a concept you learned last year during the pandemic. I don't know if you did or not, and what the algebra teachers were teaching last year while you guys were all home. Completing the square. Anybody?
I think we did some, but I don't really remember.
Completing the square. Yes, maybe, no. Will, back me up here.
I don't really remember.
I remember learning about it, but I don't remember. We did it like one day, and
Okay.
I remember nothing else.
I figured that was it, or nothing at all. That's what I was prepared for today. So I'm going to go, and I'm sorry ahead of time, but I'm going to go painstakingly slow through this process. And just because you didn't know it last year is not an excuse to do poorly on it this year. All right? It's really not too bad. You just got to get reps at it. All right. So we're going to do a method called completing the square to turn this into center radius form. Step number 1. Rewrite your equation so your x's and your y's are together. Okay? Rewrite the equation so x's and y's stay together. So for instance, x squared should be right next to my negative 8x. So I'm just moving parts around so x and y are next to each other. Plus y squared and the 2y right next to it. And this one, and in this problem, this is already done, but if the single number is not over to the other side, it needs to be moved there. Called the constant, the one without a variable, needs to be moved to the other side if it's not there already. All right, we're good. That was an easy first step, right? All right, now we start completing the square. And we are going to do it twice. One for the x's, and we're going to do it once for the y's. We are going to complete the square for the x's and the y's. So what we need to find out is the following. To complete the square, we're going to add a number to the x's, and we're going to add another number to the y's to complete the square. The question is, how do you compute that number I'm going to add? Anybody remember that part from your completing the square days?
I remember doing this.
Okay, well that's good. Anybody remember what I need to do to find that number?
Why are you adding a number?
Because you'll see why in a second. You'll see why. Anybody remember the process to finding that number that will complete the square? Okay, maybe when I show you, you'll remember. This number that I'm going to add can be found doing the following. We all agree there's an a and a b value up here for the x's, right? Like if I was doing quadratic formula, there's an a and a b value, correct? You're going to take half the b value divided by 2, and square it. Anybody coming back? And nope, a little bit. Nope. All right, never mind. And that's what I'm going to do over here too. I'm going to take half my b value on the y's and square it. That'll give me the number that completes the square. All right, ready? What's the b value on the x's? Negative 8 divided by, think in your head right now, divided by 2. Negative 4. Square it. There you go. That's the number that completes the square, 16. Negative 8 divided by 2 is negative 4. Squared, I get 16. All right, what about on the y's now? What's my b value now? 2 divided by 2. 1. 1 squared. 1. Hold on, though. Well, before I move on to the next step, we got a problem right now. And I'm sorry, you guys at home probably can't see this visual. I'll do the best I can. Here's what just happened. We were here, and then we did the 16 and the 1, and now we're here. And I'm not talking little teapot here. We were here, and then we found the 16 and the 1, and now we're here. What am I talking about here? It's unbalanced. What do you guys know all your whole math career? I do one side of the equal sign, got to match it on the other side. Got to match it on the other side. So on the other side, I need to add 16 and 1 as well to keep it balanced. All right, so that's how I find that number. Now, watch what I mean by completing the square. Maybe this goes back to your question. X squared minus 8x plus 16, factor it. X squared minus 8x plus 16. Two numbers that multiply to 16 but add to negative 8. Negative 4. Oh, negative 4. They're always the same. So watch over the side. X minus 4, X minus 4. How can I rewrite that a little bit more professionally? X minus 4 all. Oh, now we're starting to look like that equation we talked about today. Aren't we? And that, Maeve, is called completing the square. All right? Plus, can somebody factor y squared plus 2y plus 1? Two numbers that multiply to 1 but add to 2. Y plus 1. Y plus 1, professionally written as what? Y plus 1 all. Oh. Equal to, oh, look at that beautiful number on this side. What's this equal to? Negative 8 plus 16 plus 1. Negative 8 plus 16 plus 1. 9. No tricks. And look what do you have? Center radius form. We've been working on all today. There you go. What's your center? 4, negative 1. And what's my radius length? 3. There it is. 4. And then up, down, left, and right 3 units. Hey, 1 does not make us great. We got 1 more to do before the end of class. Ready to go? At home, ready to go? All right, you'll notice on this last one, it's in standard form. All right, this is in standard form. So again, we need to get it into center radius form. First step, rearrange everything so your x's are together and your y's. And in this case, look, the constant 40 needs to go to the other side. X squared plus 8x plus y squared minus 14y now equals negative 40. All right, now I need to find the number that will complete the square. Make sure, again, I'll remind you guys, it's only our second one. To find the number that completes the square, half your b value squared. Half your b value squared. I'll give you a second, then I'm going to ask somebody what your numbers were. Bless you. All right, what are your numbers here that complete the square? 6. Caroline, here you go. What number for the x's completes the square?
16.
Good job. 4 squared, which is 16. And then how about for the y's?
49.
Good. Negative 7 squared, which is 49. Perfect. Just to remember, It's unbalanced when you do that. It's unbalanced to the left, so make sure you add 16 and 49 to the right. All right, now we make it look like circle radius form. X squared plus 8x plus 16, what would that factor into? And it should be, remember, when we're doing completing the square, those numbers should be the same. 4 and 4, so x plus 4, all squared. And then at y squared minus 14y plus 49. Minus 7, right? So plus, is anybody picking up on a pattern here at all? That you really don't have to factor that at that point. Where could I have gotten 4 and negative 7 from? Or let me ask this, where have I already gotten it from? Where did I get positive 4 and negative 7 from already in this problem? It's half your b value. Yes. Okay, it's half your b value. So if you don't want to factor, these numbers here are just half your b value. But if you want to factor because you don't want to remember that much, I'm fine with that too. And what's that nice, beautiful number on the right? Oh yeah, 25. Love it when it's a perfect square. So there it is. So just let me know the center and radius form, or center and just the radius. We're already in center and radius form. 14. Here we go. Ellie, back to you. Got the center for me here, Ellie?
Is it 4 negative 7?
Well, that's what I plugged into the formula. But now
Negative 4, 7.
There you go. And then how about the radius if I got a 25 over there?
It's 5.
Yes, it is. Good. Good job. All right. And then we graph it. Please pay attention to the directions tonight. They're on your bottom of your packet. I do not want you to graph on the graphing questions. I just want you to get it into center radius form and get the center and radius out for me. That's it. Please do not graph. But there will be two completing the square problems, maybe 3, but I think 2. Pretty mathematical. Yeah, I'm ready.
Instead of actually completing the square, could you just say 2 divided by 2 before you added like?
Okay. Everyone always asks me that. They're just like, hey, at the beginning, can I just divide by 2 and that's what should go into? Yes, but here's the problem.
25. Okay.
You need to know what you're adding so you can add on to the other side. All right. So yeah, what's up?
Do we have to do the homework on graph paper?
No, you just don't. I don't want you to graph. The directions will say in your textbook for a few of them graph, but don't graph it. Just do what we did here to find the center and radius. All right, guys. Good luck tonight. Behave. Be smart. I'll see you guys tomorrow for the last day of circle unit. The last day.
How long has it been?
It seems like forever.
Are we gonna have one more quiz and then a test, or are we just gonna?
No, we're just having quiz 3 and then we're done.
Okay.
I can't give you guys a test on all this.
Yeah.
Especially if you guys were all in class, yeah, I'd be all about it. But
Yeah.
it would take if your day was, if you're a remote student, it would take you forever to take it.
Should we be studying circumference?
Well, proofs are going to be on there.
Right.
Not circumference or length of an arc, no, but theorems, yes. Any theorem is going to be fair game that we learn because we're going to have proofs on that.
Okay.
Well, we started this unit on March 19th. So, nice solid month. All right, you guys have a good one. See you back on Monday in class.
Backyard games. I think that's like same.
Thank you.
See you, Zach.